Okay, for section 12.2, there we go. For section 12.2, we're going to talk about measures of central tendency. And as kind of a generalized definition, we have that measures of central tendency are statistical values that describe the center or typical value in a set of data. They help summarize a large set of numbers with a single value that represents what is average or most common in the data set. And we have four measures of central tendency we're going to look at in this set of notes. Three of them you've probably heard about. The fourth one might be new, but luckily it's really easy to calculate. Okay, so let's go ahead and dive in with our first measure of central tendency, which is the mean. Okay, now you might know the mean as the average. So they mean the same thing. So if I say find the mean or find the average, same difference, okay? So as a definition, we have that the mean of a data set is the sum of all data items divided by the number of items in your list. I will tell you that a lot of times we use n to equal the number of data items. So go ahead and kind of get that in your head. We're going to think in a lot. Okay, we talked about this briefly, I believe, in the previous video when we were talking about frequency distributions. The total of all the frequencies is n, which is the number of data items. Okay, now for us, we do need to make note of something. The mean, when you're calculating it, it's really sensitive to extreme values. So if you have a data set that's kind of all clumped together and then you have this one value that's like really high or really low compared to the others, your mean is going to always be pulled towards that extreme value. So do use caution when you use the mean, okay? Finding the mean is just finding the mean. So the way we calculate it is just the way we calculate it. But when you're kind of making comparisons and you're thinking about like the center of the data set or what's most common, again, the mean is going to be sensitive to those extreme values. So again, if you have one really high value in a data set, your mean is going to be kind of pulled towards that. And I'll show you that in an example down here. So just make note, the mean is sensitive to extreme values, okay? Now, we do have a formula. So I'm going to show you this formula. It's very technical, okay? You've seen bits of this formula before. I want to say we showed little pieces of this, maybe, I want to say maybe in chapter 11, but I feel like you've seen part of this formula. So anyway, let's look at the formula here, okay? So a couple of things to make note of. We have the formula. First, X bar is the symbol we use for the mean, okay? So if we ever see an X with a little line over top of it, it's pronounced, we say X bar, and that just is the symbol we use to represent the mean. In this, we have this little critter. This is the summation symbol. And it quite literally just means add them up. Okay, so we're going to have the summation symbol, and then whatever comes after that is what we're going to add up. And so what comes after that is X. Well, X represents the individual data items. So what this says so far is X bar equals the mean equals, and then we have the summation symbol and X. So that says it equals the sum of the data values. And then we divide it by N, which is the number of data values, okay? So just know that this formula right here means all of this, okay? So again, in short, we just add up all the data items and then divide by the number of data items in the list, okay? So let's practice. We're going to find the mean. If you don't have your calculator out, please get your calculator out. I'm not going to switch back and forth to the different screens too often. There's going to be a couple things I'll show you with the calculator on the calculator screen, but otherwise just do your calculations on your own handheld. Okay, so it says for example one, find the mean of each situation below. For part A, you have started exercising 5 days a week. For the first week, you exercise for the following number of minutes. So day one, 78 minutes, day two, 85 minutes, day three, 92 minutes, day four, 88 minutes, and then day five, 77 minutes. What is the mean number? That just means what is the average? What is the mean number of minutes spent working out each day this week? So if you were to take the number of minutes that you worked out each day and find a weekly average, on average, how many minutes did you work out per day? So we would say X bar equals, and we want to add up the individual data items. So we had 78, 85, 92, 88, and 77. We're going to add all those up. And we have 5 individual data items, so we're going to divide by 5. So using your handheld calculator, let's figure out what the sum is. So 78 plus 85 plus 92 plus 88 plus 77. I get 420 divided by 5. And if we go ahead and do that division, we would get that X bar equals 84 minutes. So on average, you worked out 84 minutes a day. Now, of course, some days you worked out less than that, some days you worked out more than that, but on average, about 84 minutes a day during your 5-day exercise work week, okay? Or exercise week. Part B. A driver records the distance in kilometers they drive on a full tank of gas for 5 weeks. The values are as follows in order by week. Week 1, they drove 420 miles. Week 2, 390 miles. Week 4, 400 or I think week 3, 415 miles. Week 4, 400 miles. And then week 5, 395 miles. So this was week 1, 2, 3, 4, and 5. Let's go ahead and find our mean. So we want to add up all of the different individual mileages, or not mileages, but number of kilometers driven. And again, we have 5 data items. So we're going to divide by 5. So let's add up the numerator of this formula. So let's see, 420 plus 390 plus 415 plus 400 plus 395. I get 2020. And then we want to divide that by 5, and that's going to tell us that X bar is divided by 5, 404 kilometers. So over those 5 weeks, on average, you drove about 404 kilometers a week. Again, some weeks you drove less than that, some weeks you drove more than that, but on average, we'd say it was about 404 kilometers a week. Okay? Now, up here in blue, I'll put a big star by it. I said that the mean is sensitive to extreme values. So we're going to kind of look at something where you can see how those extreme values will pull your mean one way or the other. Okay. So for example 2, it says find the mean of each set of test scores below. Okay. So we're assuming these are 4 test scores for some class. Okay. Let's say some math class. All right. So in example A, we had test scores of 72, 74, 82, and 77. And what you can see is all 4 of those test scores, they're pretty close together. They're within 10 points of each other from highest to lowest, okay? So they're clumped pretty close together. So we would expect our mean to be somewhere in the upper 70s probably, okay? So let's go ahead and see what our mean is. We would take 72 plus 74 plus 82 plus 77, and then we would divide by 4. So again, using your handheld, let's see what we get. We get 72 plus 74 plus 82 plus 77. I get 305 divided by 4. And then once we take that 304 and actually, or 305 and actually divide it by 4, we get 76.25. And that seems very reasonable, okay? Of course, you have a couple of test scores less than that. You have a couple of test scores over that. But on average, this person has a test score average of 76, okay? And that seems reasonable, all right? But in example B, or example 2, part B, we have the first 3 test scores are the same. So we have a 72, a 74, and 82. But then we have this one oddball of 100. You can see it's quite a bit more than the other test scores. So let's see what it does to our mean, okay? So we have 72 plus 74 plus 82 plus 100. And we divide by 2. So let's see what we get for our sum. So 72 plus 74 plus 82 plus 100. I get 328. Don't forget we still have to divide by 4. So we divide by 4 and I get 82. All right, so you can see that score of 100, it pulled our average up a good bit, okay? We had originally an average of 76, 82 is 6 points higher than that. So you can see here we had 2 scores lower, 1 score that was exactly the mean, and then we have this just 1 test score that's higher. So that score of 100, it pulled our mean up. Okay, now let's see what happens in the reverse. If we have a test score that's lower than everything else, let's see what that does to the mean. Okay, so for part C, we have the first 3 test scores are the same, 72, 74, 82, but the 4th test score is way, way lower. So we get 72 plus 74 plus 82 plus 35. We want to divide everything by 4. So let's see what we get for our sum. 72 plus 74 plus 82 plus 35. I get 263, again, divided by 4. So let's see what x bar is going to be. I get 65.75. So you can see by having this one really low test score, it pulled our mean down, okay? So our mean was originally 76.25. It pulled it down to 65.75 by just having that one test score that was lower. So it dropped our test score average by about 10 points. So just be mindful, make note that the mean, again, is sensitive to extreme values. And all that means is if you have a lot of scores or a lot of values that are kind of clumped together, and then you have this one oddball, whether higher or lower than everything else, your mean is going to be drawn towards that oddball value. Okay, so your mean is going to be sensitive to like one really wild, like kind of off the wall value. Okay, now one other thing that we can do is we can find the mean of a frequency distribution. Okay. So in the previous worksheet, so 12.1, we talked about frequency distributions. This is one of the ways that we can organize a set of data. So you organize data based on how often a data item or a group of data items shows up in a data set. And as long as you're dealing with a frequency distribution where you're looking at just individual data items, you can find the mean, okay? So what we have here in example 3 is it says, find the mean for the provided frequency distribution. Well, how on earth would we do that? Well, remember, when you have a frequency distribution, you have some value. In this case, we have 30. And then we have a frequency of 3. So that means that secretly this is 30, 30, and then 30. So that represents 3 data items, each of which is a 30. Next, we have a 33. It has a frequency of 4. So that means we would have 33 listed 4 times. Fix that one, I messed it up. And then next we have 40, which also shows up 4 times. So 40, 40, 40, 40, and then we have 50, which just shows up once. So this is our actual data set, okay? The frequency distribution just gives us kind of a quicker, easier way to represent that data. And since you have data items that show up repeatedly, instead of adding all of these individual data items, we can take each data item, multiply it by its frequency, and then add those up and divide by the total number of data items, okay? Now, how do we get the total number of data items? All we have to do is add up the frequency. Okay, now remember, we use a lowercase n to represent the number of data items. And our first data item had a frequency of 3. Our second data item had a frequency of 4. The third data item had a frequency of 4. The fourth data item only showed up once, so its frequency was just 1. And if we add up all of the frequencies, that tells us how many individual data items we had in our set. So 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 1 is 12. So we had 12 data items, okay? And if you look at this listed out set of data, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 data items. So you can see, guarantee we have 12 data items. Now, we do have a formula for finding the mean of a frequency distribution. Okay, so we have that wacky summation symbol again. So again, X bar just means the mean. All right, we have the weird summation symbol. And the summation symbol just says add up whatever comes after this. And what we have now is X times F. Well, remember, X is each individual data item. And then F is the frequency of each data item. So basically, we take each data item, multiply it by its frequency, and then add up those products. And then just don't forget we divide by n, which is the number of data items in the list. So let's go ahead and do this. So for example 3, we want to find the mean for this frequency distribution. We have scores. I don't know what the scores represent, some score in some game. We have a score of 30, which occurred 3 times. So we're going to take 30 times 3. We have a score of 33, which occurred 4 times. We have a score of 40, which occurred 4 times. And then we have a score of 50, which occurred once. And then we need to divide all of that by 12. So let's see what we get. Again, use your handheld. We have 30 times 3 plus 33 times 4 plus 40 times 4 plus 50 times 1. And I get 432. So if I take 30 times 3, that's 90. 33 times 4 is 132. 40 times 4 is 160. 50 times 1 is 50. Add those up. You get 432. We want to divide it by 12. And we get that the mean of this data set is not, hold on, I typed that in wrong. Don't put 11. It's definitely not. I was like, that seems awfully low. 432 divided by 12. We get 36. That's much better. So we get a mean of 36. Okay. So again, you take your scores, your individual data items, multiply them by their frequency, add up those products, and then divide by the number of data items you have. And that's how you can find the mean of a frequency distribution. So we've talked about just calculating the mean. We have this formula here. We looked at how the extreme values can pull your mean up or down. And then we looked at finding the mean of a frequency distribution. In the next video, we'll talk about the median of a data set.